All right, the final presentation of this section is gesture recognition using Kinect. During the demo session, if you see a bunch of people doing this, in front of that, you'll understand why they're doing that based on their presentation. So this is team number 1.
Good morning. We're Team Connections, and our project is gesture recognition using the Kinect. Professor Konrad is our customer, and the team members are Amro, Mike, John, Albert, and myself, Ankita. So the objective of our project was to create a user-friendly interactive display showcasing gesture recognition in the realms of informational, browsing, gaming, camera vision, and social media. On here you can see some examples of how our system works. We have menus, we have cameras that are here on the 9th floor, it looks down on Konrad. We have a social media application, we have game, and we have faculty directory. So what is the purpose of our project? Well, there are touch panels downstairs, and they have an informational display. But incoming freshmen and prospective students are not very sure about what ECE does and the cool applications. So we are taking those touch screens and making it more interactive for the user by using gestures.
So I guess first off, what do we mean when we talk about gestures? Our whole project is based around the Microsoft Kinect, and what happens is when the Kinect sees you, it generates a skeletal structure, which you'll see here. And what a gesture is, in terms of our project, is some movement by the users, so like this or something. And all the gestures are 1 second in our system, so 30 frames a second. And what we're doing is we're looking at specific nodes in the skeleton structure, specifically your left and right hand and elbow node. So our gesture engine is what we call the module that contains our gesture recognition algorithm, which was created by our thesis student Cam Live last year in conjunction with Professor Konrad. And at a very high level, how it works is you have some library of predefined gestures, and when the user makes a new gesture, the algorithm will work through all the gestures in the library and say, okay, here's my input and here's the distance from this input to each gesture in the library. So you have this array of distances, and then the algorithm will output the shortest distance as long as the distance is below some certain accuracy threshold. So this is just like a block diagram of what happens. You can take the skeletal structure into the gesture engine, and it outputs some ID. The ID just being an integer corresponding to a gesture, -1 if it's outside of that threshold. So a little bit more in detail of what's going on is when you perform a gesture, it's represented as a 13 by 13 covariance matrix. 13 comes from, we're tracking 4 nodes, so X, Y, Z positions. So there's 12 components, and the last component is time. The gestures in the library are 100 by 91 HC, so it's a covariance matrix. So it's symmetric. So you only need 1/2 of it, either the upper half or the lower half. So what happens is in the library, you have essentially 100 takes of some given gesture. So when we're actually training these gestures, we're just standing in front of the Kinect doing this 100 times. So what happens when the algorithm is running is it's looking, so for gesture 0 in the library, we'll look through each 100 takes, compute the distance to all 100 takes, whatever the smallest distance is, be the distance of that gesture. So just like a quick analysis of how fast this runs. If S is defined as the number of, or S is the size of the matrix, where N is the number of nodes being tracked, and S is 3n plus 1, our algorithm for gesture recognition now, we run in S squared time, which in practice is only order of milliseconds, so it's pretty quick. But we actually implement a delay on top of this to improve accuracy, so you don't get double recognition. Like if you do this, you don't want to recognize like the motion after that to get back to a neutral state. So this is just like a very high level diagram of what's going on. So you have the Kinect outputting skeletal structure to the gesture engine. Gesture engine is taking the skeletal structure, comparing it to what's in the library, outputs an ID. This goes to our decision tree, which is essentially a state machine of our whole system, which John will get into later. This has an initial state based on where you are in the cube just receptor for meaning. So this will output to the command generator the next state, which will generate a command to update rooms.
Okay, so this is kind of a very high-level view of an example of what the home interface looks like. We just wanted to represent it as a cube. We felt it's a very kind of intuitive, tool that users can use to interact with the system, and also it helps to deal a little bit with the learning curve of learning to do different gestures, so you can swipe around and kind of get a feel for how everything works. On top of that, this is also basically I'll talk about this later, but it's the hub from which you can open different applications. We wanted to kind of implement an application-based approach where users can put new applications in later if they want to update things or if they want to add, new games, new browsing, techniques, something like that. They can easily link that with this kind of main application hub. Okay, so for the project specifications, we wanted first we use an engine that's built in C# using the SlimDX API. This is a DirectX wrapper, and we decided to choose this layout for two reasons. So the first one is compatibility. We received code from our customer, which is written in C#. We wanted to choose a framework that would allow us to integrate seamlessly. SlimDX also has a smaller learning curve as opposed to using an unmanaged DirectX in C++, which better fit the time constraints of a senior design project. Also, in terms of usability, we felt like there's more options for expansion with SlimDX. If you're using DirectX, you can add more features. You can add anti-aliasing. You can put in new sprites, all kinds of things that you want. And also, as well, you get a more aesthetically pleasing interface as opposed to using something like WinForms or kind of an older, version of some sort of framework like that.
So that was John actually performing gestures, and then this is what zoomed in what the cube is actually doing. Just to, we can talk over that until you actually see it.
Alright, so we have multiple applications in our cube. One of them is the ECE directory. It's a source of information about the ECE department. This includes news, faculty, events, and the Beat shuttle. To show the specific information selected, we take the corresponding link to open it in an embedded browser in WPF. The links are taken from RSS feeds created from overdabber.net, and because RSS feeds pull data from a website, as soon as the website is updated, it updates the RSS feed. To create the graphical interface, we use FluidKit library. We use this because it's a toolkit that allows you to dynamically move images around the screen. And it just gives the application a very interactive feel because as a user is doing gestures, images can pop up and shift around.
Another application we have is the Twitter application, in which we have the newsfeed and photobooth. So the newsfeed is basically the timeline that our connections account can see. So this is just news from different people we follow. And we use the link to Twitter application, which allows us to use the Twitter APIs in order to access information displayed on the user's timeline. We have a Twitter engine which uses user control to initialize connection with the Twitter APIs using the link to Twitter library. And this allows us to pull the information that is needed to populate the newsfeed. And this is an example.
So we also included a photo booth application inside this Twitter application. So first, it shows a RGB video stream in WPF. This is done by enabling the Kinect color stream, and we had to create an event handler for each new color stream frame. In the event handler, we convert the color stream to a bitmap, and we set the image source to the bitmap image. And this is going at 30 frames per second, so, and we use the link to Twitter tweet with media function to be able to tweet an image to our Team Connections user account. It just grabs the current frame tweet and tweets it to the timeline.
Okay, next we have the cameras application. So if any of you have ever used the touchscreens downstairs, there is an option that you can enter some rooftop cameras on top of photonics, and basically you can pan around and look at different views of Boston. So we wanted to implement that using the Kinect to be able to do this exact same thing. So a user can enter, and using gestures they can rotate and move the cameras. You can pan and zoom, and just showcase the functionality of connecting with the camera stream on the rooftops, and also to use gestures to make it.
So we also implemented a game, Pac-Man, and obviously since we're using the Kinect, it's not going to work like traditional Pac-Man. So the movement is all controlled by motion tracking. So you see the arrows pointing at this kind of quadrant space, and the center quadrant right now is highlighted. So that's indicating the position of your right hand. So essentially what happens is when you start up the application, we'll look at for the initial position of your right hand, and it'll ask you to stay still while it initializes. And then it will map the XY space around you into quadrants shown here. And the selected quadrants in the image should correspond to essentially the movements for Pac-Man. So if you go up, your character will start moving up. And so essentially you're doing this to control Pac-Man instead of using arrows.
Okay, and finally, we had one requirement for our system, which was to implement some kind of modularity. So the system was designed for this, and the Cube home screen, which I kind of touched on briefly before, offers an app-based approach, allowing apps to be added or removed from the system. The home screen itself has a lot of different methods embedded inside that you can change camera views, or again, like I said, you can add new objects, take them away very easily. And so this sandbox will allow future developers to make changes to the system, adding new games. So now that Professor Konrad was showcasing some sort of a new gesture algorithm, different techniques for recognizing gestures. So who knows, that could come into the next version as well. So thank you very much, and I have any questions.
So I think in the case of a touchscreen, usually when you first approach it, there's usually something indicating what you need to do. So like touch here to begin or something like that. Do you guys consider what would happen to somebody walking by has no idea that this is a gesture-based interface, or what the gestures might be to interact with it? Is there anything to kind of guide them to get them started?
So we have documentation for all, like, obviously it's much easier to perform a gesture if you actually see it being done. So we have videos of all that at random and whatnot. And in terms of going by it, and like, you don't want it to be responding as people walk by and whatnot, obviously. So what happens is the Kinect, when it's tracking someone, so if you're using it and you move out of the frame essentially and it's not tracking anyone anymore, it'll lock
Does this have any way of handling multiple people in a frame?
Right now, we do not have that functionality, so it'll recognize the person that's closest to the Kinect and will block out the people.
Oh, but it won't cause an issue that somebody else may be standing nearby.
How stable is the system? How long can you run it until it crashes?
Right now, those are some issues we had before. So I think that we fixed the bug that was causing the slowdown. At least yesterday, this last week, it's been running over 60 frames per second, so it seems to be pretty stable
But
over time.
Okay, so how long is the longest that you can have experience that now you run it?
Right now, we've been probably about 10, 15 minutes.
But yeah, with no, I mean, essentially what we're trying to do is we open and close the application to see if there's any slowdown, but I mean, there's not as of right now, so theoretically it should.
Have you run it like for days?
Yeah, I think as long as we cover up with it, an hour, 2 hours,
Yeah.
just lower.
So this is primarily intended for an audience to be the consumer of information, right? So they can't, you don't have in your vision, or maybe you do, I don't know, the ability for someone to enter data or like an email or something into the system. Would that be a possibility for your system?
It could be a possibility, but there would need to be some sort of method for inputting the data. And I mean, obviously you don't have a keyboard, you don't have a touch screen, so that's something that you would need some sort of, need to think of kind of a way to be able to, for example, type using gestures. So
But right now you're just a
right now it's
consumer.
mainly consumption of information besides before we do this application, which lets you help.
I know you've been playing with this quite extensively. Can you give a sense of if you had someone as a new user who's never used the system before, does it require any training on his part, or is it fairly insensitive to the type of user?
So as you definitely need to see the gestures being. If I just say do like an up gesture, you're not going to know what I'm talking about. But if you see the gestures be performed beforehand and just walk into it, I mean, we've had friends and roommates come and try it out. I'd say like a couple minutes learning curve.
If there's a new Kinect on the market, actually, just coming out new Kinect, and there's ACES as action, and there's coming out with motion, how difficult would it be to integrate one of these devices instead of a Kinect if they provide this similar data? Is this a question of swapping SDK, or is it more complicated?
Yeah, it's pretty much swapping the SDK. I mean, if, for example, what you gave us, which was basically the gesture engine we turned it into, if there was another one of those, it's literally plug and play, because the only thing you need to do is add the reference to the library, the SDK that you have, and then everything else, it's very modular. So that shouldn't be a problem.
Thank you.